Records. Now we can start. Hello, Mariam, Leila, Ilkin, Sarah. Anybody else here? We have Sarah, Ilkin, Leila, Mariam, and that's it, I think. Good. Okay, guys, good to see you again. I hope you are having a good day. Today is International Women's Day, right? Mariam, Leila, are you going to celebrate or already celebrated?
Already celebrated, actually.
Did you go to school today?
No.
No. So how did you celebrate at home?
Yes, at home.
Good. All right. Here, actually, it's not a big celebration. It's just only see on Facebook or something, but it's not like people do not celebrate like in Azerbaijan or Uzbekistan or Russia. It is just normal day here. It's just a public holiday. Anyway, Leila, Mariam, Ilkin, Leila, you sent me a message. I think, is it you, right? You told me that some questions you couldn't solve. Is it you, if I'm not wrong? Yeah, okay, good. Very good, Leila. If you are trying and practicing these questions, that's good. This is how you should study. Solve it. And if you have no idea, put a question mark, try again. Still you have no idea, bring those questions here and we can discuss together. Now, guys, first, I want to finish this paper. If you remember, like 4 or 5 questions left. So let's finish those questions. And after that, we will practice new paper, okay? And after that, maybe next week, we will get back to the topics, okay? And maybe we will learn some topics or we will work on a specific topic, okay? Not Sasmo questions. So let's just move. We already did these questions. I think we stopped here, okay? 22, 21, 23, 24, 25. All right. These are, as you know, actually, the first 10 questions or the first 15 questions are a bit easy questions. And from 15 or maybe 10 or let's say 12 to 20 questions are a little bit harder. And from 20 to 25, they are the hardest questions in Sasmo. I'm not saying very hard, but in the paper, those questions are harder than the other questions. And that's why you need to think a little bit carefully, okay? And try to answer the question. Okay. Mariam, let's start with you. Can you read the question first? Let's try to understand. After that, we will discuss its solution.
Okay. A book contains 80 colored pens, 36 black, 24 blue, 12 red, and 8 green. Alice takes some pens from the box without looking at the colors of the pens. What is the least number of pens she must take so that she has at least 20 pens of the same color?
Did you understand the question? I mean, we did the similar one before, right? We did similar one, but not that many, but it was maybe a few, maybe like 15, I think. Okay. For example, let me just give a break, okay? Let's remember the question. I really want to see this once again because we did with you. All right. Like if you remember in this paper with a similar question. Okay. All right. What? Where did you solve that question? The 5 box, 5 colors. Okay. This one, I just want to show this one. Do you remember this question, Leila, Ilke, Mariam? A bag contains a total of 15 balls of five different colors. Each color has a unique number of balls in the bag. What is the least number of balls to be picked without looking to ensure three different color balls are picked? What is it? It is 11. Anyway, and I just want to make sure that we did similar question. Okay, that is very similar question here. Okay, not share. Okay. So now, how are we going to solve this question? First, think a little bit. Okay, let's just 2 minutes. All right. And after that, what idea comes to you, let me know. And after that, we will solve this question. Okay. That is a little bit hard question. You need to think carefully. Okay. So the question is, what is the least number of pens she must take so that she has at least 20 pens of the same color? So that means that 100% we are sure that you need to tell me the number that it's a constant. If I pick like 40 pens, I am 100% sure that 20 pens of the same color will be in my hands. Okay, that's the question. Think a little bit, and after that we will discuss together. Let's see who gets what. And write your answer in the chat box if you can answer this in 2 minutes. Okay. 20 or 36, Leila. What do you mean? That must be one answer only. One answer. And the answer is greater than 40. Mm. You can know that's not the correct answer. Let's wait for Mariam, and after that, Mariam, did you get anything?
I'm trying to get something, but
Mariam,
I
are you
didn't get
thinking
something.
or are you solving now?
And I'm thinking and solving together by the both of the things.
Okay. Okay. All right, let's do this together now. Here, the problem is, understanding the problem is a big problem, And after that, you understand the problem, then solving is not a big problem. Because a lot of times these kind of questions, students or we people, we don't know how to find or what to find. Okay. So what is the question here? All right, we know that a box contains 80 colored pens, 36 black, 24 blue, 12 red, and 8 green, right? Alice takes some pens from the box. And here it says that without looking, that is a keyword here, without looking, okay? And the colors of the pens. You just close your eyes and just pick the balls, okay? Now the question is, what is the least number of pens she must take so that she has at least 20 pens of the same color, okay? So now every time, if you just pick, for example, black, black, black, black, black, then when you just pick 20 pens, it will be black, right? The same color, right? Or maybe blue, blue, blue, blue, right? It's the same color. But what is the possibility that this happens? It is very low possibility, right? Or probability, let's say. And this point now, in this kind of questions, I need to think of the worst scenario. What is the worst scenario? Each time I pick the pen, it is this different color, okay? For example, let's say I pick the first pen, it is black. The second one, it is blue. Third one, it is red and green. Okay. Again, I continue. Again, I pick another one, black. It is blue. And here we have red. And this one is green. So now, actually, I'll just continue this. Okay, picking this until no more green left. Okay, here we have red. And this one is green. So now how many pens we already picked here? So this one is, we have 8 green, right? So each one is 4. So already I picked, what is it? 32 pens here, 32 pens. But now I have 8 pens of the same color, right? In the question, we are expecting that, okay? Even in the worst scenario, I'm 100% sure that I will have 20 pens of the same color. But now I have 8 pens of the same color. Now I will continue picking the pens. Now again, I pick another one that is black, another one it is blue, another one it is red, and another one it is blue, black, red, blue, black, red, and blue, black, red. Okay, so now we have no more reds left, right? Because we have only 12 reds. How many pens I pick here? It is 3 times 4. Here we have 12, right? So that means that now we have 4. Actually, here we have 8, right? Now I have 12 pens of the same color, right? So altogether, how many? Here we have 44, right? So now here we have 8 plus 4, 12. I need to pick 8 more. So now look, I will just continue here, okay, because I need more space. How many different colors left here, Ilkin? Only black and blue, right?
Yes.
Because now we don't have any more red, we don't have any more green. Now we have only black and blue. So I will continue. Here I have 8 and 4, 12 different colors. I need to pick 8 more. Okay, the first one is, let me just write here, black, blue, black, blue, and the black, instead of black, blue, how about if I just count 1, 1, 1, 1? It's much easier, okay? 1 black, 1 blue, 1 black, 1 blue, 1 black, 1 blue, 1 black, 1 blue. It is 4, 5, 6, 7. I want to stop here, okay? How many did I pick already? Here we have 7. 7 times 2. Now we have 14, okay? Here we have 32. Here we have 12. It is 44. And here we have 14 more. It is 58, okay? So now the last row is important, okay? And some students make a mistake here. So now in the last actually pick, it doesn't matter. You just pick black one or blue one, all right? If I just black or blue, it doesn't matter. Suppose that I get black, okay? So now here I have how many of the same? Here we have 44, right? 44 of the same color. And how about here? We have It is 14, right? And I have one more, right? Now I have at least 20 pens of the same color. Or I have at least 20 of, what is it? The same color of what? It is blue color. Okay, so how many cards should I pick so that 100% I'm sure that at least I will have 20 pens of the same color. So here we have, let me just write in red. It is 32 plus 12 and plus I picked actually 14. But in the last one, I don't have to pick two, right? Either blue or black, it will be fine. So here we have one, which is equal to 44, 58. It is 59. So the answer is 59. Okay, one more time, Marianne, you should understand that. What do we mean by 59? Okay, 59. If I just put 36 black and 24 blue and 12 red and 8 green pens in a bag, okay, and you just close your eyes, and if you just pick 59 cards, 59 pens, 100% we are sure that we will have at least 20 pens of the same color. And what colors are they? Either you will have 20 black pens or either 20 blue pens. Marianne, did you understand the logic here? What we mean here?
Yes. Yes, understood.
Good, good. If you understand, let's move on. How about this question, Mariam, İlkin, Leyla, Sara? Did you try to solve this question?
I
If not,
tried at home, but I didn't get. I tried just 15 minutes, if not more, but I didn't get anything.
really? I
Yes.
want to show you one thing. Look here. Let me give you a hint. Okay, then you will try. Here we have 2. Look at the denominators. This one is 6. This one is 12. And this one is 20. And this one is 990, right? What are these numbers? If I write here, for example, 2 is equal to 1 times 2, right? And how about 6? It is 2 times 3. And how about 12? It is 3 times 4. And how about 20? It is 4 times 5. Dot, dot, dot. And the last one is 9900. It is 99 times 100. Okay. What is this? What are these actually? These are the product of 2 consecutive positive integers, right? 1 and 2 consecutive positive integers, or let's say whole numbers. 2 and 3, 3 and 4, 4 and 5, 5 and 6. Another one. How about if you simplify this? 1 over m minus 1 over m plus 1. How do we simplify these two fractions? We have to bring into the common denominator, right? The first one multiplied by m plus 1. 1 times m plus 1, it is m plus 1 over m times m plus 1. Minus the second one multiplied by m. 1 times m, it is m. Denominator m times m plus 1. Now denominators are the same, right? So we just draw a single fraction line. Here we have m plus 1. And here we have numerator m plus 1 minus m. This m cancels each other. That's equal to 1 over m times m plus 1. Okay, that is very important formula. Usually they ask in math Olympiads. So now, from here, what should we understand from here? The idea is, look at this. Now, if I have 1 over 2, right? What is 1 over 2? I can write it as 1 over 1 times 2. So according to this formula, right? 1 times 1 plus 1 is 2, right? I can just write it according to this. I can write it as 1 over 1 minus 1 over 2. If you simplify this, I get 1 over 2. And how about 1 over 6, for example? I can write it as 1 over 2 times 3, right? And that's equal to 1 over 2 minus 1 over 3. And in this way, for example, 1 over 12, what is it? It is 1 over 3 times 4, which is equal to 1 over 3 minus 1 over 4. Or let me write here, 1 over 20, right? We can write it as 1 over 4 times 5. That is 1 over 4 minus 1 over 5. In this way, the last one, what is 1 over 9900? We know that 9900 is 99 times 100. So I can write it as 1 over 99 minus 1 over 100. Okay. Suppose that this sum, let me just label this by S. Okay. So now I can write this sum here. What is this sum? The sum is equal to, instead of 1 over 2, I can write 1 minus 1 over 2. Plus, instead of 1 over 6, I can write 1 over 2 minus 1 over 3. Plus, instead of 1 over 12, I can write 1 over 3 minus 1 over 4. Instead of 1 over 20, I can write 1 over 4 minus 1 over 5. The same thing continues, and the last actually fraction is 1 over 9900. Instead of 1 over 990, I can write these two things, right? 1 over 99 minus 1 over 100 equals. Layla, can you see the pattern here? What is minus 1 over 2 plus 1 over 2?
2.
0. Minus 1 over 2 plus 1 over 2. What is it? 0. Right? That is 0. And minus 1 over 3 plus 1 over 3, it is 0. Minus 1 over 4 plus 4, it is 0. And minus 1 over 5 plus 5, it is 0. And this continues. Also, this has a pair. It is 0. What is left here? Only the first number, right? That is 1 minus the last fraction. That is 1 over 100, which is equal to 1 is 100 over 100 minus 1 over 100, which is equal to 100 minus 1, that is 99 over 100. So this fraction is equal to 199 over 100. Okay, Leila, Mariam, Ilkin, is it clear?
Yes, clear.
And this is
Yes.
called in math, how do you call this? Actually, this method in math, we call this telescopic
Shrine.
methods. Why? Here, if you count from here until 1 to, what is it, 2 to 9900, right? A lot of numbers, right? It's with telescope, right? We are not just making this very short. And that's why it's called telescopic method, or just telescope method, or telescopic methods. Okay. So usually, guys, if you are given a lot of fractions, either the sum or difference, I don't know, depending on the question, usually you need to use this method, okay? Can you create like plus, minus, plus, minus, plus, minus numbers? And you just cancel all of these numbers. Usually only the first number is left and the last number is left, and simplify these two numbers and you get the result. Okay, Leila? Ilkin, any questions?
No.
All right, now let's move to the next question then. Guys, we did a lot of similar questions with you, right? In geometry part, you did solve at least 35 questions. It's also that kind of question, a little bit different, but similar. Give it a try. Okay, you have 2.5 minutes. Let's see if we can solve this question correctly. And after 2.5 minutes, we'll discuss together. Leila, really? How did you get it? Huh? Are you guessing or you really solve this problem?
I'm solve and get this answer.
How did you solve it? How?
Um, so this is, um,
Okay. Mariam, any answer?
I think my answer is too big. Too.
What is it? Is it more than 50 or less than 50?
No, more than 50. I think that, okay, that the perimeter of four rectangles is 40 centimeters. I think the one side of the square is 40 centimeters. We can find area of 40 square. It's 1,600, I think, the area.
Oh.
Yeah,
No, no,
it's so
actually,
big.
Leila's answer is correct. I don't know how Leila solved this. Leila's answer is 25. But that's the correct answer.
I'm divide 30 and um,
Mr. Kazım,
Yes, Ilkin.
can I say?
Yes. But Ilkin, what did you get? What's your answer, Ilkin? Huh?
My I can't find answer, but I did this.
Okay. Guys, let's do this.
For example,
Let's do this together. Yes, yes, Ilkin, I'm listening to you. Tell me.
I divide this this square for this rectangle for A and B, and I have got for A and for B.
But Ilkin, did you get any answer? Did you have any result?
Yes. My answer is 25. But
Really? Also, your answer is 25?
yes,
Good.
isn't it?
All right. Ilkin, Leila, okay, listen, let's do this together, okay?
Mr.
So if
Kazım,
you,
I divided 40 and um, divided for 4, it is A, and multiplied by 5 because A is 5.
okay. Now listen carefully. Here in the question, it says that the diagram shows a square, right? That means that the original figure is a square, right? So that means that let me just name this one is one. Let's say the top, bottom, left, and right all sides are equal, okay? Because I don't want to label anything, otherwise it will be messy. So now being divided into 4 rectangles, if the sum of the perimeter of the 4 rectangles is 40, find the area of the square, okay? So we are talking about the perimeter. Look, let me just write like this, starting from here. This width, let's say it is A, and this side it is B, okay? This length it is C, and this one is D. And this side actually it is opposite, right? Also that's equal to B because they are equal, right? Top and bottom, right? And this one it is A, right? So now even I can just write like this. For example, I know that actually B is equal to B. How about if I write like this? A plus B plus C plus D. Let me just write here. This one is E, and this one is F, and this one is G, and this one is H. Okay. So now just one thing. We are going to use this formula. We know that if this one is length, actually it's length, it is width. What is the perimeter of this rectangle, Ilkin? It is 2 times length plus width, right? Or width plus length. Okay, I'm just going to use this formula now. Here, let's say we are talking about the perimeter of 4 rectangles. That is P1 plus P2 plus P3 plus P4. That is equal to 40, right? So now, Mariam, can you tell me what is P1? Let me just start from here. That is 2 times, let me just write, this one is P1, this one is P2, this one is P3, and this one is P4. What is P1? It is 2 times A plus H, right?
Yes, A plus H.
Plus, and how about P2? It is 2 times B plus C, right?
Correct.
Plus, and how about P3? 2 times D plus E, right? Plus, and how about P4? 2 times, what is it? F plus G. On the right hand side, I have 40. What is 40? 40 is 2 times 20. So now this 2, 2, 2, 2, right? It's a common factor. I can just take this out. If I take this out, I have here A. Let me just write in actually red. You can see this much better. I have A plus B plus C plus D plus E plus F plus G plus H. Now I'm going to write them in alphabetical order. What we have here then? A plus B plus C plus D plus E plus F plus G plus H. On the right hand side, we have 2 times 20. Now this 2 cancels each other. Okay. Mariam, can you tell me what is this?
This is a half perimeter of this square. Yes.
That is the perimeter of
Square.
big
Yes.
square, right? Big
Uh-huh.
square, or just simply square.
Mhm.
And how do you find the perimeter of the big square? It is just 4 times side length, right?
Yes.
So that is 4 times side length is equal to 20. And suppose the one side length is x. That means that what is x? X equals 20 over 4. That's equal to 5. Then what is the area? Area is just one side is squared. That's equal to 25 centimeters squared. Okay, I mean, that is a general way how to find this, but in different ways, shorter way, can you find this or not? I don't know. Because here, you know, you just actually label all the sides, and you should be able to see that the sum of all of these sides, right? And the one side of this rectangle, it gives us the perimeter of the big square. And if you divide it by 4, it gives us one side length of the square. And to find the area, we should just square the side length, right? It gives us the area. So that's why the area of the big square is 25 square, what is this, centimeter square. Ilkin, did you understand everything?
Yes, Mr. President. In
Good.
100%, yes. I understand
Good.
this.
Okay. I mean, in other way, you may just give a guess, but even if they change the number, for example, with this idea, we can solve any problem similar to this. Okay. How about this question? Very easy question. Given that 5 factorial, we just read this in math, 5 factorial, right? Actually, this means, what is it? Factorial. So what does factorial means? Factorial means the product of the first n natural numbers. 5 factorial means 5 times 4 times 3 times 2 times 1, right? For example, 6 factorial, what is it? It is 1 times 2 times 3 times 4 times 5 times 6. So now if it is so, what is the last digit of 2014 factorial? What is it? What do you think? What is the last digits? What? Elmira, what is the last digits?
Maybe 6.
Maybe 6. Sarah, what do you think?
Yes, I think 6 too, but I'm not sure.
Mariam, what do you think?
No idea. I didn't understand
How
this.
come no idea? How come no idea? Look at this. Until
I didn't
2014.
understand this.
What does 2014 factorial mean? It is 1 times 2 times 3 times 4 times 5 times dot dot. And the last digit is 2014. Just simply, for example, what is 2 times 5?
10.
That means if you multiply any number by 10, the last digit will be 0.
Oh.
But actually here, until 2014, how many zeros we have? A lot, right? Not only last digit, maybe the last 5, 10 digits will be 0. So the last digit will be 0. I mean, just 0. Okay? Because here we are multiplying numbers from 1 to 2014. For example, we have 100, right? So 100 times any number, that means that the last digit will be 0. So that's why the last digit of this number is 0.
Sarcasm.
Yes.
But I can't understand this. Why 2 times 5 is 0? I can't
Look,
understand.
here, if you multiply, for example, if we multiply the first 5 numbers, what is the last digits? 0, right? Because here I have 2 times 5. 2 times 5 is 10. So now 10 times anything, the last digit will be 0. So now here you are multiplying 2014 numbers, starting from 1 until 2014. So what do you think? The last digit of this number will be what? 0, right? Actually, not only last digit, we have a lot of zeros at the end of this number. Even, for example, let's say 2014, right? Factorial. I can just write it as 1 times 2 times 3 times 4 times 5 times, and until 2014, just label this with something, okay? Until from 6, for example. Just only this number, because of this 2 times 5, I have 10. I don't have to calculate anything, right? And you are multiplying some big number by 10. That means that the last digit is 0. Okay. All right. Maybe the first time you see this notation, that's why it may be confused, but it's very easy. But just that's why, that is why they put this question here, to introduce you with this notation. Now, because every Math Olympiad questions, usually they actually have questions related to this factorial. Simple, but you have to think a little bit. But this one is very easy question. You are primary 6, right? For example, in primary 6, they may ask what are the last 2 digits? And for example, secondary 3 or grade 8 or 9, and the similar question they ask like this: if you just calculate this number 2014 factorial, how many zeros will be at the end of this number, for example? But now you should be introduced with this notation. So the next time when you see this notation, you will not get surprised. You know, that's factorial. It is the product of the first and natural numbers, right? And the problem. Anyway. Okay, Mariam, can you read the question?
Yes, 2 women, Anne and Carol, and 2 men, Bob and David, are athletes. One is a swimmer, a second is a skater, and the third is a gymnast, and fourth is a tennis player. On one day, they were seated around a square table. The swimmer sat on the end's left, the gymnast sat across from Bob, Carol and David sat next to each other, a woman sat on the skater's left. Who is the tennis player?
Okay. So that's the question. I want you to think a little bit. After that, we will answer the question. So they are sitting on a square table, right? Square table. So now we don't know who is sitting where, but this information is given. So using this information, what can we draw a conclusion that this guy is the tennis player? Okay, what is it? We have 2 women. You should know that from Anne and Carol, they are women. And Bob and David, these people are men, right? So actually one of them is skater, one of them is gymnast, one of them is tennis player, and one of them is swimmer. And using this information, can you find out who is a tennis player here? You have 2.5 minutes. Okay, after that we will discuss together. Let's see who can find the correct answer, right answer. Elmira, are you doing this question? Did you understand?
Yes, I understand. I try to solve it.
Okay, what do you mean by B? What do you mean?
Correct answer is B. Is it not?
I think, did you understand the question? Okay, here the question is, who is the tennis player? Anne or Carol or Bob or David?
Okay. Once.
Mariam, any answer?
Yes, I thank you.
Anne, are you sure?
No, my answer is David. I think David.
Mariam, Davids, Elmira. Elmira, how did you get Anne? Tell me. Elmira, did you really solve it or you're just guessing?
No, I try to solve it, but I don't know it's exactly or not.
Okay. Actually, Elmira's answer is N. N is correct. Elmira's answer is correct. N. Okay, guys, let's do this. Mariam and Ilkin, Leila, Elmira, and who else? Nobody? Okay. Only 3 students. Okay, let's do one by one. Here, important thing is here they are saying women and men. Also, we need to know actually who is women here, who is men, right? So Anne and Carol, they are women. Bob and David, they are gentlemen or men, right? The swimmer sat on Anne's left. We are just starting. So it means that where Anne is sitting, it doesn't matter, right? I can just say, suppose that Anne is sitting here, okay? If Anne is sitting here, what is the swimmer? It says the swimmer sat on Anne's left, right? And this one is left, this one is right, right? Just sitting and facing to this side, right? So the swimmer is sat on Anne's left, the swimmer is here. This guy is a swimmer, right? But I don't know who is a swimmer. Okay, we are done with this. The second one, the gymnast sat across from Bob, right? So, for example, Mariam, can I write Bob here?
If across, yes.
No, it
Okay.
says that the gymnast
Ah,
sets across Bob, right? If it is Bob, actually this must be gymnast, right? Opposite.
yes, yes.
So he cannot. Actually, Bob cannot
Yes.
sit here because if Bob sits here, this instead of swimmer, he must be gymnast. So Bob cannot be here. Bob cannot sit here, right? So where can he sit? Bob can sit either here, right? Or here. Right here, Bob at the bottom, he cannot sit here. It's not possible because if he's sitting here, opposite Bob sat across, right? Who's sitting? Gymnast. But here we know that here in this table, right? In this chair, swimmer is sitting. So we have two possibilities for Bob, either here or here. I don't know which one is. Okay, we are done with this. Now Carol and David sat next to each other, right? So Carol and David, for example, if Bob sits here, can you see here? At that time, Carol and David, can they sit next to each other? They cannot, right? Next to each other means one guy is sitting here, another guy is sitting here, right? Next to each other. Or one guy is sitting here, another guy is sitting here, right? Next to each other. You understand? That's why actually, if Bob is sitting here in the opposite end, so this Carol and David, they cannot sit next to each other, which means that Bob must be sitting at the top. Okay, so now, I don't know, Carol, David, maybe Carol is sitting here, David is here. Or maybe David is sitting here, Carol is sitting here, okay? Let's see which one is it. So now we know that Carol is women, right? A woman sat on skater's left, right? A woman sat skater's left. For example, if Carol is sitting here, right? Okay, gymnast sat across from Bob, right? So Bob is sitting here, Bob is sitting here. That means that gymnast is here because gymnast is sitting across Bob, right? Okay. And Carol and David sit next to each other. A woman sat on the skater's left, right? And as you see here, skater, who is skater? Skater's left. If David is sitting here, right? David is gymnast, right? And this Anne, right? It cannot be here because it says that a woman sat on the skater's left. So that means that here, who is sitting here? This must be Carol, and this must be David, right? And as see here, this Carol is sitting on skater's lap. What is Carol's job here? It is skater. It is skater. Swimmer, gymnast, skater. What is that here? Tennis player, right? So that means that Anne is a tennis player. So dot, dot, dot. Anne is a tennis player. İlkin, Mariam, Leila, did you understand?
Yes,
It's a bit
easy.
logical question you have to think, okay, because every word, for example, the swimmer sat on Anne's left, that means that Anne can sit anywhere. So let's just start from here. So suppose that Anne is sitting here, that means that we are sure that here this guy is swimmer. And a gymnast sat across from Bob, right? Bob cannot sit at the bottom because at the bottom opposite this gymnast, the swimmer is sitting, right? So that means that Bob must be sitting at the top. And Carol and David sat next to each other. That's why Carol is sitting here, or David and Carol. And women sat on the skater's left. So if David is sitting here on the left of David, C, right? That is, what is it? Everything is, I mean, how to say, everything is correct with this seating. So guys, I really suggest you to try once again what is going on here, all right? And that's a logical question. It really improves your thinking skill, how things are working here, okay? So that's it. Okay, now I'm closing this. Okay, we can just do maybe one or two questions. That's it for, what is it, P5, and we need to practice some P6 questions now. P5. Okay. All right. We have only 4 minutes left. At least let's have a look, okay, and start maybe 2 questions we can solve together. And next time we will continue from here. This P6, similar questions. Now they are a little bit harder than P5 questions. Okay, you are 6A. Today is 8th of March. Okay. So again, we have 25 questions and time for these questions is 100 minutes. And you have to do all the questions. And as you know, the first 10 questions are easy questions. Leila, can you read the first question?
A clock takes 3 seconds to make 4 chimes. Assuming that the rate of chiming is a constant and the duration of each chime is
Negligible.
negligible, how long does the clock take to make 8 chimes?
Chimes, right? And negligible means we can just ignore, okay? We don't have to take this into account. And here, that's a rate problem, actually. Here we have 3 seconds, right, to make 4 chimes. The question is, how to make 8 chimes, right, at the same rate? So it is multiplied by 2. It is 6 seconds multiplied by 2. It is 8 chimes. What is the answer? It takes 6 seconds, right? Next question, Mariam, read the question and tell me the answer quickly.
If n is a whole number, for the first values of n is a 36 over n also a whole number.
Okay. What are actually the possible values of n? So the 36 over n is also a whole number.
The values of n may be 1, 2, 3, 6.
How about 4?
No, 4. Yes, 4, 2, 6, 9, 12, and 36.
How about 18?
18 and 36.
Yes, you should be careful, Mariam. Even if you just miss one number, that means your answer will be wrong. It must be 100% correct. Simply, what is it? For 36 over n to be a whole number, n must be, what is it? The factors of 36, right? All of these numbers are, what is it? Factors of 36. The last number, Ilkin, read the question.
Find the smallest whole number between 1 and 10 is divisible by
100, 1 and 100.
Yes. It's 60.
What is it?
60.
60, right? Because divisible by 12 and 30. So divisible by 30, they are 30, 60, and 90. But 30 is not divisible by 12. But 60 is divisible by 30 and 12. So the answer is 60. Very good. Let me stop here. We will continue from here. Let's also finish this paper, okay? This 2014. We have 2 more years. We have to go a bit faster. Let's see, okay? Now we will also solve 2015, 2016, and I hope you will actually the question become much easier for you. Thank you very much, guys. Happy International Ladies Day to all girls here. All right, enjoy your day. I will meet you on Thursday, okay? Maybe also I will drop these questions. If you have time, try to practice some questions from here. See you on Thursday. Bye-bye.
Thank you. Goodbye.
Thank you.
Thank you for lesson. Bye bye.
Thank you for the lesson.
Thank you again, Elmira.
See you next time.
Bye, Mr. Kazan.
See you. Yeah, thank you.